Okay, class, we will look at a application right now. Okay, we have a question right here. All right, there's a 100-pound of weight hang from two wires as shown in the figure. So there's a wire here, there's a wire there. Okay, find the tension force T1 and T2 on the wire T1 and T2. All right, and the magnitude of its tensions. Okay, so how much the force and also in terms of vector as your tension force. Okay, so this is what we're going to do. All right, so we will first from an observations of a quote unquote balance system. What I call a system. Let you see. So I have a wire T1 right here and T2. Probably that's not a good one. Let's do that again. So T1 and T2. Okay, and then the weight itself is here. I'm going to call this as a vector 0. Pay attention here is minus 100 because the direction is down toward down, so minus. So I'm going to look at a balance system, meaning I'm going to add, because T1, T2 was able to work together to maintain, allow the 100-pound hanging here. So I'm going to do this. I'm going to add these two vectors together. Okay, so there is a balancing vector. So this I'm going to call it T1 plus T2. So these two actually cancel out. Okay, so these two actually cancel out. Okay, all right, I'm going to also call it down here, maybe it's minus 100J. So you can see this add together should be equal to 100 or 100J in order to balance this one. So become added together becomes 0. So it's called equilibrium system. So everybody's happy. All right. So I'm going to say we shall look at this in a different way. We shall look at T1 and T2 in terms of length and trigonometry functions. How do I do that? All right, let me make a copy of that first. Like so. All right, I'm going to just make a copy right here. This thing graph. All right, so let me just go ahead and erase some of the things we don't want. All right, we keep everything here, right? So what I'm going to do is this, right? I'm going to say the T1 right here, let's make it a little larger. All right, the T1 right here. Aha, there's two magnitudes to constitute that, right? So I'm going to call, because we know originally questions here is 50 degree, meaning this will be what? 50 degree. And originally here, if it's just 50, 32 degree, here will be 32 degree. Let's go back here. That will be, let's go ahead and erase this T2 first. And that will be 32 degree. Okay, so the magnitude or the component, this dotted line constitute the component. So if this length is T1, this length is T2, the length. So according to this degree, right here, the length here is the opposite, so that will be T1 sine 50 degree. And this will be T1 cosine 50 degrees. Similarly, this will be T2 length cosine 32 degree. this side will be T2 sine 32 degree. So I can say T1 is actually, in the component-wise, all right, because this is facing to the left, I'm going to say negative cosine 50 degree. And the second component will be what? T1 sine 50 degree. I'm going to say T2 equals to, all right, the x coordinate is T2 cosine 32 degree. It's not negative because we're going to the right. And T2 sine 32 degree. Okay, so this is what we want, right? We can say that. However, we know that T1 at T2 should be equals to 0, 100, or 100j if you like, because you look at this, right? This sum balance out this bottom. So if the weight itself is negative 100j, then what? The T1 plus T2 should be positive 100j. So added together to what? These two added together will cancel out, become 0, 0. So become a balanced system. So now we have these two in mind, we can solve the equation now, can we not? So we can say, if these two add together equals to 100j, can I just not say the first one? We form a system of linear equations, right? And what are they? So the first add together equal to 0, so negative length of the magnitude of T1 cosine 50 degree plus this guy, the T2 cosine 32 degree equals to, should be equals to 0. The second equation is the y component, right? Y component, you have this guy, so it's T1 sine 50 degree plus this guy right here, right? That will be the length of T2 sine 32 degree. And the sum should be equals to, right here, 100. Okay, so what's it called this equation 1? Call this equation 2. So now we have two variables, right? The variable is what? The length of T1 and the length of T2. We have two equations. We know we can solve it. So cosine 50, sine 50, cosine 32, sine 32 degree are just coefficient. That's just constant number. Let's keep it like this, all right? So let's do substitution first. So from equation 1, we know that this guy T2, I'm going to isolate that, equals to the length of T1 cosine 50 degree divided by cosine 32 degree. I have that. All right. Then we substitute this into equation 2. So all the T2 replaces like that. So we get is T1 sine 50 degree. So replace T2 by this guy. T1 cosine 50 degree cosine 32 degree. All right, so that's just the T2 and times sine 32 degree equals to 100. Whew. Well, remember, the only thing we're interested in solving this. Okay, so if you factor that one out, divide everything on the right-hand side. So left-hand side, you have left is this. Right-hand side is 100 divided by all this junk right there. So sine 50 degree plus magnitude of T1 cosine 50 degree divided by cosine 32 degree, okay, times sine, plus 100. I'm sorry, no, the 100 is on denominator. Okay, that's it. So this value, after we calculate it, I'm sorry, that's equal to 100, right? Yeah, we got that. So this is about use a calculator. This is about, let's see, 85.64 pounds. Well, after you solve T1, then T2 simply equals to T1 length times cosine 50 degree over cosine 32 degree. That's about 64.91 pounds. Okay, so we can say T1 equals to what? So T1, the magnitude is negative, because remember T1, the T1, the first component is negative, so it's negative. The magnitude 85.464 times cosine what? Times cosine 50 degree, and it's negative. Well, the second one's positive, right? So positive 85.64 times sine 50 degree, and it's about negative 55.05 as a vector and 65.6. And T2 is 64.91 times cosine 32 degree, 64.91 times sine 32 degree, and that's about almost equal, right? 55.05 and 34.40. You say, hey, these forces are identical. Of course, if you look at here, that's left and right, they have to be equal to be same. Otherwise, it's going to swing from side to side, or swing from one side to the other. Okay, so these two will cancel out the horizontal force. So these two forces, they cancel out the horizontal forces. So the answer is what? The answer is the tension T1 equals to negative 55.05 I plus 65.6 J. T2 equals to, T2 equals to 55.05 I. These two cancel out, plus 34.40 J. All right, so the magnitude to T1 is 85.64 and T2 is 64.91. All right, so that's the answer. So what do? We simply use trigonometry, okay? But the thing is recognizing from physics that when you have two wires here balanced with a 100-pound downward speed, there's a two tension force, T1 and T2. They form a what? They form a counter force. So T1 plus T2 will add what? Actually what? Balance out this negative 100J. Okay, negative 100J. And we use the fact and then use the trigonometry, we can figure out what? The answer. Okay, so here's the application. Now we have some homework coming your way.